Okay. Good morning everybody. Today we are going to learn now again regarding the image formation by a convex mirror. So this case, actually in convex mirror only two cases will be there. When object is at any position other than infinity and at infinity. Okay. So this case is about rear view mirror case, because in cars and bikes also, without turning back you can see who is coming back. Okay, so that mirror, if you touch like this, it will be raised outside, right? So this is convex mirror. So painting is done on the inner side and the light reflection takes place on the outer side. So now, for example, the object is somewhere here. You no need to say the position at what you call at F, at C, or between F and C, or beyond C. No need to say anything. Simply you write like this at any position other than infinity. Simply, right? Now the light ray will come like this. In the infinity case, I'll say only no need to draw even AB object also. Simply you have to draw parallel lines. Okay, so that also I'll say afterwards. Okay, for now you understand this. Now the light ray which is coming parallel to principal axis, it will go like this. Okay, means the light ray which will reflect here, it will appear to come from what, for example, this is going like this. It will appear to come from a point called F here, right? Another light ray which was going to meet at C, means like this. The light ray which was going to meet at C like this, okay, pass through C like this, that light ray will come and rebounds back. So for a person who is seeing, like a driver, for example, here you are the driver, you are seeing, for you these two light rays are meeting here now. So for you, okay, the objects back of you will appear to come from here. So this is means A dash B dash is the object. So if you want, what I will do, A dash B dash I will draw with a red pen so that you will understand better. So here is A dash B dash, here A, so red marker. Okay, this is A dash B dash. So here you have to keep the dotted lines path because the image formed is virtual and erect. Okay, so now what we will do, we will write the position and all. See, position, what is the position of image? The image is formed beyond behind the mirror, you can say behind mirror. And the nature of image, what is the nature of image? The image is formed, the image will be virtual and erect. And the size is diminished. Okay, you can say diminished, you can say. So now case 2 we will go. This is case 1. What about case 2? Now let us go to the case 2. Case 2, even you no need to show the object also. Simply you have to take the light rays, you have to take the light rays like this, means the light rays which are coming from infinity, means when the object is at infinity. Here you write when the object at infinity. Okay, so see here. Now for example, this is the principal axis, the light rays are coming from this okay, infinity. So somewhere, it means that somewhere here some object might be there, that's it. So light rays will be coming like this and they go like this. So for a person who is on the object side, that is the right side, according to this diagram, okay, so for that person these light rays will appear to come from this point. Okay, so here the image will be formed, and when you write the nature of image and all, you can say like this, position of image, you can write like this, position of image is at F, position of image is at F. At F means focal point. And what is the nature of the image? Virtual and erect. See, always real will be inverted and virtual will be erect. Okay, so nature of image, virtual and erect. Always, in the sense, why always means, I said you already, this whenever you are using only one optical device like a concave mirror or convex mirror or concave lens, convex lens, etc., that time it will be like that. If you use more than one, that time it will change. In your inter second year and all, you will come to know using both concave and convex lens or mirror, or one lens and one mirror, like that, that time it will change. But now when you are using only one optical device, virtual will be erect only. Now size of the image, it will be highly diminished, you are right, size of the image is highly diminished. Now what I will do, I will explain about sign convention and I will explain about the formulas. So these compulsory you have to remember. Okay, so now what I am saying is this mirror formula I will write first. See here, what is this mirror formula is, Mirror formula is 1 by V minus 1 by U is equal to 1 by F. So what is V? V is the object distance, U is the V is the image distance, U is the object distance, F is the focal length of the mirror, right? Now, so you can write what does V stands. V stands for distance of image from pole. Distance of image from pole. From pole means from pole of the mirror or from mirror. Okay, from pole of the mirror you can say. And what is U? U is object distance, means distance of object from the object from pole. Okay, pole P of the mirror, and F is focal length. Okay, so like that you can write. And what is the other formula you have to learn is one more formula. M is equal to, okay, V by U is equal to height of image by height of object. So this formula. So formula number 1, formula number 2. Now these are the two formulas you have for mirror. Now I will rub the board. I will explain about sign convention and some numericals. Okay, that we will do. Okay, and if you want anybody to know the image formation, nature, position or anything, you can pause the video and see it properly and do. And in exam, I forgot to say one more thing. In exam, a question will be asked in exam. Why we are using a convex mirror as a rear view mirror? So simply you have to write the reason like this. This word should be seen in your answer because the image format will be erect. Okay, and one more answer will be you asked. One more question will be asked. What is the question is? For example, some means generally though this for this question erect image it is done, but another question sometimes might be asked. What is that is in see generally for convex mirror the size of the image, if you keep a limit, okay, a question will be asked like this: why a convex mirror is used instead of a plane mirror of the same size? Okay, I repeat the question: why a convex mirror is used as a rear view mirror then a plane mirror of the same size? Okay, so for that question what will happen is a convex mirror, you will write the answer like this: a convex mirror will give a larger field of view than a plane mirror of the same size. Okay, larger field of view you can say, or you can say instead of larger, some people say it as wider field of view, like that. Field of view means you can cover larger area by using this. So these are the answers you have to write. If the evaluator will see these points, okay, these words in your answer, definitely they will give the marks. Okay, so these words should be seen in the answer. Why a convex mirror is used as a rear view mirror means because a virtual erect image should be there. Of course virtual, if you want, okay, additional word you can write virtual also, virtual and erect. Okay, but erect is more important, and then larger field of view. So these are the two words you are supposed to write. Okay, now coming to the next sign convention, I'll explain. See, generally based on sign convention only you can do many numericals on the mirror chapter. Okay, and generally what is the first rule in the sign convention? First rule in the sign convention is all distances are measured from the pole of the mirror. So that is the first point in sign convention. And what is the second point? Second point in sign convention is the distances measured in the direction of the light ray are taken positive, and the distances measured in the opposite direction of the light ray are taken negative. That is the second point. And what is the third point? Distances measured above the axis, means above the principal axis, are taken positive, and distances measured below the principal axis are taken negative. Means I will explain in detail. For example, see, generally in your state syllabus you will take the object. For example, you take a concave mirror. Okay, what you are doing, you will take the object on the right side. Okay, for example, you are taking object like this. So for example, now this is pole. Okay, so light ray will come from right to left. So for example, this is your right hand, okay, right side. Okay, this is my right hand, right side, and left. So it is coming. So right to left it is coming. So the light ray will go like this. But when you take the object distance you have to take this point as like origin, generally 0, like pole. So you are measuring distance from pole to what? From pole to object. For example, you simply write like this. For example, for now, so not to confuse, I am rubbing this so that you won't confuse here. Object distance, how you will measure is, where is the object? Here is the object. Here is the object. From here to here, what is the distance? U. So what is happening? U value you have to take negative, means for example if they say object distance as 20 centimeters, so you have to take minus 20 centimeters. Okay, why? Because you are measuring from left to right the distance, but whereas the object the light ray is coming from right to left. So these points you have to remember. First one, see, for example, all distances are measured from pole. So that is one sign convention. First point, are measured from pole of the mirror. This is the first point. Okay, so this is about sign convention in mirrors. Sign convention in mirrors. Second one, all distances are measured from the pole. Okay, done. The distances measured, okay, the distances measured opposite to the direction of light ray are taken negative, and that same direction are positive. So what we will do, we will do like this: distances measured in the direction of light ray, in the direction means in the same direction, are taken positive, and whereas the distances measured in the opposite direction are taken negative. Okay, so this is one thing. So that is the reason, see, generally always remember U will be negative always, generally. Why? Because you will measure opposite, okay, to the direction of light ray. Even if you take convex also, for example, if you are taking convex mirror, so light ray will come, for example, object is here, light ray will come from right to left, but when you take the object distance from here to here, you are measuring from pole na? So you are measuring left to right. This is left, this is right. So that is the reason U will be always negative, remember that. And remember, both in mirror and lens also, convex means the focal length will be positive, concave means the focal length will be negative. Why? I will say you the reason. Here what is happening, distance, the light ray is coming from right to left, distance you are measuring from left to right. So this focal length, this is F. So focal length will be the distance between P and F, okay, that is focal length. So F is positive in generally positive in convex, and concave negative. Okay, what F? Concave F will be negative and convex F will be positive. So this you have to remember, okay, both in lenses and mirror. So since here we have mirror, we are writing mirror, but generally even in lens also you can take lens, okay. So why? Sir, why in convex this one positive is because here you are measuring like this now. So here F will be there. So you are measuring distance from P to F. Light ray is coming from right to left, and you are measuring the distance also from right to left. So that is the reason F is positive. Okay. Now third point, the distances taken above the x-axis means height of the object. Generally, if you are taking above, so you have to take it as positive. Okay. So whether it is height of the object or height of image, whatever it is, generally we have to take positive. So generally we don't take generally the object down, generally means below the axis. Always when we are taking object, you will take above the axis. So what do you have to write here? You have to write like this. So distances measured above the axis are positive. Okay, above axis or positive. Axis means what? A principal axis are positive. Okay, or positive, right? Otherwise above the axis are positive, and distances measured, okay, below, and distances measured below the axis, below the axis are taken negative, okay. So this you remember, right? Now coming to the next, these are about sign convention done, but one more important thing I want to do other than sign convention. Okay, sign convention until here it is done, okay, done to do the problem, but this fourth and fifth point is also very important to say about nature of the image. See, generally I give the formula. What are the formulas? See, the two formulas I gave is 1 by V minus 1 by U is equal to 1 by F, and M is equal to, in case of mirror, V by U is equal to HI by HO, right? So now if M value means numerically, you write like this, numerically means number wise, don't take sign, okay. If M is less than 1, the image will be diminished, okay. if the m is equal to 1, the image will be same size, and if the m value is greater than 1, then you have to say it as the image will be enlarged. Or see, enlarged in some books it is given as magnified. In some books it is given as magnified. So whether you say enlarged or otherwise magnified, the meaning is the same, right? Now coming to the next, okay, m is equal to greater than, and this is m is less than. Now another point what I am saying is, fifth one, whenever you want to say whether the image formed in numericals, whether it is virtual erect or real inverted, that time if m is negative, then the image formed will be real and inverted, real and inverted, and inverted. Okay. Now if m is positive, then image formed will be virtual and erect, virtual and erect. So this you have to remember. Okay, this is about sign convention. So we have to do some numericals based on the sign convention. Okay, so now what we will do, we will, based on these sign conventions, we can do the numericals. And one more thing, if you apply sign convention, okay, the light ray is coming from right to left, and when you measure the image distance, you are getting the image distance as negative. Why? Because we are measuring from left to right. Okay. Other than sign convention also, some people what they say is, they will say like this also. What, for example, you take randomly any case. For example, what we will do, we will imagine Cartesian coordinate system here. Okay, coordinate system. Then also you will be negative. How? I will say you. See, generally when you take Cartesian coordinate system, always the object should be taken to the left side. So what I mean to say is, whether you take object left side or right side, you will be negative. I mean to say, u means object distance. How? For example, I will say you. For example, you are imagining yourself the concave mirror on the, okay, on the Cartesian coordinate system, so that the pole will be origin. Now if you take the object like this, then what will happen? The light ray will be going, of course, okay, like this, and it will be coming like this. So generally what will happen, when you measure the object distance you will measure from pole, na? So you are measuring from pole, correct only, but what you are doing, you are measuring negative x-axis. Okay, so negative x-axis when you measure, definitely you will get u as negative. That is one thing. Another thing is, light ray is going from this, for example, this is my left hand, left to right it is going, but you are measuring from right to left, you are measuring the distance, means all distances are measured from the pole, na? So based on that also you will be negative. Understood? Same way for concave, focal length will be negative. Why? Because the light ray is coming from left to right, but whereas the distance we are measuring focal length from here to here as right to left, means this is right to left we are coming. So that is the reason what will happen, if you apply the Cartesian coordinate system also, okay, the u will be negative only, and focal length for concave will be negative, and for convex it will be positive. Like that everything will be applied as it is, no problem. So that is the reason object whether you take on the left side or right side, it doesn't make any difference. So now what we will do, we will go with one numerical. Okay, randomly you will take some numbers, some values, and we will do some problems. Okay, randomly, right? So what I will do is, now some interesting case I will see for this okay, mirror, and I will say some numerical, so that the nature of image, size of the image, everything we can say. Okay, so now until that time I will write the question, you can see in the next video. Okay, until that time I will write the question and keep ready.